All right, in today's session, we're going to be learning about a very important tool that you can use when trying to analyze the motion of object. And simply put, it's called a motion map. Motion map. All right, and as the name implies, it basically maps the motion of an object. So you might have a scenario where you have someone, let's just say, simply walking down the street. Alright, so let's just say we've got someone, they are made purely of sticks, and they're simply just walking down the street. Okay, so they're just walking down the street. A motion map is basically a series of snapshots of what's happening at specific intervals of time. So it's almost like if you were to watch someone walk down the street and you closed your eyes and then you opened them at regular intervals, you might see that they started here, and then you close your eyes, and then 1 second later you open your eyes. I'll put a little dot saying it there. Next second you open your eyes, and now they're here. Alright, same person. And then you close your eyes, and a second later you open your eyes, and they are here. And then you close your eyes. Apparently getting smaller too. But you close your eyes, you open your eyes, and then you see that they are here. And let's make them grow just a little bit. Alright, so this would be kind of a motion map. Now you'll notice on the first one I drew an arrow because we want to see, well, how are they moving? And so in each of these scenarios, let's just say that they're moving at a regular speed. They're not speeding up, they're not slowing down, they're just walking at a regular pace. What we've just done here is this is a motion map. Okay? Now this would be at time 0. This would be at time of 1 second, and this would be at time of 2 seconds. This is time of 3 seconds. So in a motion map, each dot is a specific time. And when you place these dots, they're going to be at regular intervals. We're not going to say, oh, we're going to put one at 1 second, and then 2 seconds, then 2.1 seconds. Okay, they're going to be at nice regular intervals of time. And what it does is it shows you the dots. So it's like at 1 second we were here, sorry, at 0 seconds we were here, at 1 second we're here, and so forth and so forth. And it's showing you the motion of the person. Now, another important thing, and I'm going to change my color palette on this, is we see these arrows here. Alright? These are called vectors. Now, vectors are very important in physics because they tell us two things. The size tells us the magnitude. All right, how big of a value is this? So we're talking about speeds here, so the bigger the arrow, the faster they're going. The smaller the arrow, the slower they're going. But it also tells direction because it's an arrow. So is it moving to the right? Is it moving to the left, up, down, things like that? So these two ideas are very important to physicists. All right, we want to know how big is the number, and we want to know what direction is this thing going in, positive, negative, things like that. So the idea of a vector is a constant notion that's going to be referenced over and over again. It's very important to virtually everything we do. So those are some of the key elements about a motion map. So this would be an example of me envisioning someone traveling at kind of a steady pace, or maybe I should say a constant speed, constant velocity, because now I'm human, so I probably didn't do this perfect, and I know I didn't, but the spacing between these two dots, I tried to make them uniform. This is a little bit bigger. But if the spacing seems the same, and the time intervals seem the same, then it seems to me like they covered the same amount of distance at each moment of time. And so if you cover the same distance per unit time, then you're going the same speed throughout. All right. But let's say that this was someone who was starting a race. Okay, so let's draw another picture here. So if this was someone starting a race, then they would start here at time 0, and then they would be here at the first step, but then they're here at the second step, and then they're out here. And then let's just do one more for funsies. Now they're way out here. So I can see that this distance between these dots is growing. So maybe their first step they were going this fast, the second step they were going this fast, and then they went this fast, and then they were going really fast. So here I can see, by looking at the size of the arrows, that they were going faster and faster and faster. I can also see by the direction of arrow that they were always running forward. And that t equals 4. Let's say they're going really fast. Okay. So this would be a motion map that would show an object that is speeding up over time. And I know this just by looking at it, and it conceptually makes sense to me, because if someone is running and they're covering more and more ground per each unit in time, let's say these are in seconds, then I know that they're going faster and faster and faster. And so the vectors that I've drawn reinforce what I'm seeing visually. And so those two kind of work together. Now, it is possible for people to change their minds. And so let's say we've got a scenario where someone is actually going to change their direction. All right? So then if I'm going to change my direction, let's just do a different color for fun. Purple, why not? Let's stay in this blue family. Let's say that they are starting here, and then they go forward, and they're kind of walking. It looks like a constant pace I've got right here right now, because each of these spaces are uniform, and each of... What happened to my dot? Where'd you do that? And each dot represents a moment in time. T equals 1, t equals 2, and so forth and so forth. Well, if the object stops, then this is basically the position, okay? This right here, this entire segment right here, this is like X. This is our position. Where are you physically? We could put a number to that. So they're walking along at a constant speed, so they're at a certain position. That position keeps changing. But let's say they're like, oh, look, it's a stop sign. I got to stop. Then what we do is we actually go down because they have the exact same position. So again, if I was to draw a position mark on this, so here you're at position 0, then you're at position something, 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 and then here we're just kind of staying at the same position, but time is passing. So this would be T3, T4, T5, T6. All right, so time is passing. So here we would have vectors that would show that we are moving forward. So we draw our arrows showing we're moving forward. And then here we decide to stop. And we have not moved. But let's say at this the 6th second we actually turn around. Well, if we turn around, we're going to go in the opposite direction. Well, that's very simple. We just draw an arrow. And let's say we're like, oh no, I forgot something. Well, we usually don't walk back. We don't meander. Unless it was like something bad, and then you're like, oh no, I forgot something, and you're kind of depressed. But you're like, oh no, I forgot something, I gotta hurry. So let's say we run back, and so this time we're going to go really fast. So that means that each moment in time we're going to cover more ground than we did before. So let's say this is t equals 7, and then, t equals 8. So these are seconds. So now we're covering even more ground on the way back. All right. So at 6 seconds we realize, oh no, I gotta go home. You run back, and then here there's no arrow, so I guess at 8 seconds we stopped again, because, oh, it makes sense, we're right back where we started. So it is possible to show more than one type of motion in a single motion map. It is possible to stop, to turn around. You basically just keep going down, because we don't want these to overlap each other, and then it gets too confusing. So motion maps are tools, okay? They're things you can use to try and understand the motion of an object in some sort of visual manner, because sometimes it's hard to describe. Sometimes a drawing allows you to kind of see what's really going on instead of just looking at some words and some descriptors. So use motion maps. Again, they're all about understanding vectors, looking at the size of those arrows to see what the motion is doing, looking at the direction, that's based on which way the arrow is pointing, and you can understand a lot about how objects are moving based on just drawing a simple motion map about them. So, hope that was helpful. You can check the more advanced motion map access a little later on. But until then, I will see you in the classroom.